Good afternoon, everybody. My name is Santiago Cisneros Castillo. Today's date is December 16, year 2020. This is Math 32, Probability and Statistics. I belong to Section 1, Discussion Section 3, and the topic we're going to be talking about today is variance and MAD, which just means mean average deviation. So before I get into everything, I'm just going to give an example or a definition of what MAD and variance just mean. So for variance, variance is just the average squared differences from the mean, and MAD is just the average of the absolute value differences from the mean. So with that in mind, how are they related? So they're both methods for statistical analysis and to see how data is behaved and observed, and how are they similar. They're both similar just to represent the deviation from the mean specifically. And let's get into how they actually look like and what equations you use to calculate them. So for variance, like I said, how I mentioned before, the squared, it is a summation of the data points minus the mu, which is just the mean. Then you square them, and then you divide by the total number of data points. Now for the MAD, the difference is that there's no longer a squared, now it's an absolute value. Now that's actually really important that there's one squared and one an absolute value sign, because in with certain data you have outliers, and when outliers are present, that can very skew your data and your end results. And that's why outliers are very important, specifically for the variance. And the reason for this is because if you have an outlier and you try to come up with the variance, what ends up happening is the variance actually ends up bigger, because what you're actually doing is an outlier, which is already, let's say, 30, right? Let's say your number is 30 and your mu is 3. So, and your data points, like the highest value is with 3 standard deviations is 10, and the lowest is -4. And if you have a data point of 30, then if that's the case, then 30 minus 3 is going to give you 27. But 27 squared is just such a big number divided by, and then you sum everything else up. So what I'm trying to say is, when you have an outlier, it gives more weight to that specific outlier for the variance. However, for the MAD, the weight is almost slightly mitigated because you're not squaring anything, you're just taking the absolute value sign. So the impact is much less when compared to the variance. Now, I have a question. So this question is 20 individuals that are all attend the same gym were questioned how many hours do they spend at the gym every week? And these are the data points that are given: 5, 10, 8, dot, 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 all the way down to 1, 3, and 7. All right, so first, let's do the variance calculation. And I highlighted 30 there just for emphasis. So, like I said before, the variance is this following equation. The mu, which is the mean, was calculated beforehand, which is found to be 6.2 hours. And with that in mind, you start plugging in numbers. X equals 5 in this case, so it's 5 minus your mu. You square that, plus your second data point, which is 10. So 10 minus 6.2 squared. And you do that all the way until your very last data point, which is 7. 7 minus 6.2 squared. All over your total amount of data points, which is 20. Which ends up giving you 35.98 hours squared. Yeah, it's very important too that it is also squared. So it's not the same unit when you first started. So I wanted to check something out, and I decided to change this value of 30 to 15 because 30 was such a big outlier. And when I changed this value from 30 to 15, what actually ended up happening to the variance is that the variance changed from this 35.98 hours squared to 12.06 hours squared. That's a big difference. And I did the same thing to the MAD. I calculated the MAD same way. The summation of your data points minus your mu, absolute value, divided by your total numbers of data points. So 5 minus 6.2 all the way up to the last data point, which is 7 minus 6.2. So we do all that, and I actually ended up with a value of 3.74 hours. Now, I did the same thing, decided to see what happens if I change that 30 to 15. And when I did that, my value of 3.74 hours only changed to 2.84. So that's actually huge. So outliers don't have much of an impact on MAD. They're weighted much less than when you were to compare it to something like the variance. So why is this useful and some like more real world applications? So the variance. So the variance is pretty useful. A lot of people look at stocks when they think about variance to see how much risk a certain investment has. Not only that, but you could do your own sort of calculations for variance. And let's say, for example, you play a video game and you want to see how long it takes you to finish the video game and how much you vary in hours. So, small little thing. The MAD, I had a bit more trouble on, but what I found is that if you're not normally distributed, then the MAD can be used more frequently and should be used. But if you have a normal distribution, then in which case the variance and standard deviation should be used. And I'm assuming as well that if you have MAD, then you can also do these sort of own your own small calculations, saying, oh, how long would it take me to finish a video game, you know, sort of thing. So that was everything. I want to thank everybody for the semester. I also want to say enjoy your winter break and have a good winter break. Yeah.